Wheels on the bus go round and round, round and round, round and round.
You should probably pause the video and try the warm-up and then come back and we will work on it together. So now that we're back, we're computing the length of the missing side. And this one isn't so bad because the missing part is the hypotenuse. So we'll call this leg A and we'll call this leg B, and then our hypotenuse will be C, and I'm going to use A squared plus B squared equals C squared. In other words, our first leg squared plus our second leg squared equals the hypotenuse squared. When we fill in for the variables, we get 4 squared plus 8 squared equals C squared. 4 times 4 is 16, 8 times 8 is 64, that equals C squared. When we add these together, we get 80 equals C squared. We don't want to know what C squared is, we want to know what C is. In other words, the hypotenuse. So we need to undo the square by taking the square root of it. So the square root of C squared equals the square root of 80. And the reason we're not doing plus or minus the square root of 80 because it has to be a positive number. Now, you'll note that this is not a perfect square, so this is going to be an irrational number. We could try to simplify that by saying that 80 is equal to 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, times 5. So I got 10 times 8. And notice I have 2 pairs of numbers right here. So this is 16 times 5. We could say 16 times 5. And then we could break the 80 apart and we could say that this was the square root of 16 times the square root of 5. So I broke it down into prime factors to see this. I could have did a 4 and a 4 and said 4 squared. So this is the square root of 16, which is 4 times the square root of 5. This is actually the perfect answer. 4 times the square root of 5 equals C, but we want an approximation. Let's go ahead and round that off to the nearest hundredth. I'm going to put this in my calculator, the square root of 80, and my calculator actually gives me this answer because it's one of those newer types. And then if I want the approximation, I hit that SD button and I get that C is approximately 8.9, and then it has 4, so I'm going to say 4. Again, this answer right here is the best answer. For those of you that don't understand what I did here, this is also a great answer, and this one right here is an approximation. Solve the system of equations. Now remember, this is a system. There are several ways to do it. One is to graph these. I don't want to graph this right now, so I'm going to use something called the equal values method. And what that is, if y is equal to y, then 3x plus 5 must be equal to 9x minus 13. So I'm going to set that up. 3x plus 5 is equal to 9x minus 13. And we're going to go ahead and we're going to solve this. I'm going to start by making sure that my variable terms are on the same side. This is smaller, so I'm going to choose to subtract this one. Remember, I'm subtracting because this is a positive and I need to put a negative. I'm making a 0 pair. And when I do this, this is 0. So we're left with 5 on the left and then 6x minus 13 on the right. I'm going to proceed by now adding 13 to both sides. Again, there's a 0 pair, plus 13. And what I get now is 13 plus 5 is 18. And on the right-hand side, this is 0, so we just have 6x. Now I'm going to go ahead and divide both sides by 6 to undo this. 6 times x, the opposite is to divide, and I get x is equal to 3. Now, I need to take that x equals 3, and I have to plug it into one of the original equations. I'm going to try the top one. So I'm going to use this one, and I'm going to say y equals 3 times 3 plus 5. I replace the x with 3. Now we're solving for y. Y equals 9 plus 5. Y equals 14. So the answer to this system of equations is the ordered pair or coordinate x equals 3, y equals 14. What I should really be doing now is taking this and plugging it back in and seeing if it works. But I'm going to move on to the lesson. Today's lesson is about a school bus. taking a trip and dropping off students. This problem is going to give you a chance to use the Pythagorean theorem to compute distance traveled and to compute the average speed. You are the school bus driver on a long route in a city somewhere in Mississippi. There are 52 students on your bus when you leave the school headed due north. You drive at a constant rate of 40 miles per hour for 15 minutes. And then you stop at a crossroad and let 13 students off the bus. After the students are safely out of the way, you turn right and head due east at 30 miles per hour for 40 minutes. Your second stop is another crossroad where you let 18 students off the bus. Again, you turn north and drive 60 miles per hour for half an hour. You stop at the next crossroad and drop off 9 students. Your fourth and last stop is due east. You turn to the right and drive 50 miles per hour for 12 minutes. You stop and let the kids out of the bus. What's the bus driver's name? We'll get to that one later. Okay, so here we are. We're going to draw a diagram of your trip and label the 4 bus stops. So we are going to start by looking at that there's 52 students on the bus when you leave and you head due north. So we're going to head north. So that's up. And we're starting at the school. So we're going to head north and we're going to head north up this way. And we started with 52 students. So right now there's 52 students on the bus. We are traveling at 40 miles per hour. So 40 miles per hour for 15 minutes. Now I want to change that into a fraction of an hour. And that's because we're doing 40 miles per hour. It will make it much easier. So 15 is 1/4 of an hour. That will let me see what this distance is. So from this point here to this point right here, this is 10 miles. And I'm going to keep a log here. We started with 52 students. Now it says that we let 13 students off the bus. So I'm going to subtract 13 to see how many students are still on the bus. So we have, let's see, 9 and 3. So there's 39 students left on the bus. We started with 52 students. So let's go to the next step. It says now we stopped at the crossroad and we let 13 students off the bus. So now we have 39 students. And after the students are safely out of the way, you turn right and head due east at 30 miles per hour for 40 minutes. So 30 miles per hour for 40 minutes. And we now end up here. Let's record our information. We have a total of 39 students on the bus. So I'm just going to put a little S here. We traveled for 30 miles. We traveled 30 miles per hour, 30 miles per hour, and we traveled for 40 minutes. What fraction of 40 minutes is 1 hour? So you need to be thinking about that, okay? It turns out that 2/3 of an hour is 40 minutes. 2/3 of an hour. Now, if we take and multiply this, 30 times 2/3, it will tell us how far you have driven. And it turns out it's 20 miles. Your second stop is at another crossroad where you let 18 students off the bus. So let's go ahead and write that down. We're going to let 18 students off, which means we're left with 21 students on the bus. And then we're going to turn north and drive 60 miles per hour for half an hour. So we're going to go north and we're going to travel for half an hour going 60 miles per hour until we end up here. So let's record what we did. We went 60 miles per hour. Sounds like the bus went on the freeway. And we drove for half an hour, so we don't need to convert that. And if you're going 60 miles per hour for half an hour, you will have traveled 30 miles. And during that time, we had 21 students on the bus. Now we dropped off 9 students this time. So let's subtract 9 and we end up with 12 students. And so we're going to turn right and we're going to drive for 50 miles per hour for 12 minutes, right? Until we end up here. So we went 50 miles per hour, 50 miles per hour for 12 minutes, which is 1/5 of an hour. So 1/5 of 50 miles per hour will be 10 miles. And now you stop and you let the kids out of the bus. So you had 12 students left. So 12 students got off of the bus. So we drew a diagram of our trip and we labeled the 4 stops. So we have the school, the first bus stop. So we'll call that bus stop number 1. We have our second bus stop, call that bus stop number 2. We have our third bus stop number 3. And our final destination, bus stop number 4. How far did you drive to get to the first bus stop? And how many students were left on the bus after the first group of kids got off? We've already done this, and we did show our work, but let's do that again. So we had 53 students and 13 got off, which left us a total of 39 students. We discovered that at 40 miles per hour, we were going to travel for 1/4 an hour, which meant we went a total of 10 miles. Now, if you're confused how I got that, 40 miles per hour for 1/4 an hour, you multiply and you get 40 times 1/4, and that equals 10. How far did you drive to get to the second bus stop? And what are the factors of the number of students left on the bus? We had 39, and then we let 18 off, which gives us 21. And it wants to know what the factors are. Well, 3 times 7 is equal to 21. So the factors would be 3 and 7. How far did we drive? We drove 30 miles per hour for 40 minutes, or 2/3 of an hour. When we multiply these together, we get a total distance of 20 miles. How far did you drive to get to the third bus stop? And how far have you driven total to this point? Okay, so for the third one, we drove 60 miles per hour for half an hour. So 60 times 1/2 is equal to 30 miles. Then we went 10 miles to the first stop, we went 20 miles to the second stop, and we went 30 miles to get to this last stop. So when we add that together, we get 60 miles total. What they didn't ask us was how many students are still on the bus. But let's figure that out. At the last stop, we left with 21 students still left on the bus, and it said that 9 students get off at the stop. So let's figure that out because we might need that, which leaves us with only 12 students on the bus. So there's 12 students still left on the bus. How far did you drive to the fourth bus stop? And how many students get off your bus? So we went 50 miles per hour for 1/5 of an hour. And when we multiply that, we get 10 miles. So we only drove 10 miles to the last stop. And as you recall, we had 12 students from the last bus stop left on the bus. So unless the students are going to go home with you, 12 students got off of the bus. 6. What was your approximate average speed during the entire trip? Now remember, average speed is defined as your total distance divided by your total time. We actually kind of already did that as we went along. Show your computation. Round your final answer to the nearest tenth and provide units on your solution. So the first thing most people do is they just take 4 different speeds, 40 miles per hour, 30 miles per hour, 60 miles per hour, and 50 miles per hour, and they add them up and they get 180, and then they turn around and they divide by 4. So 180 divided by 4, which gives you 45. And they would say, okay, that's 45 miles per hour average. There's a problem in this thinking. We did not go the same distance each time. So we have to look at this a little differently. We went 40 miles an hour for 10 miles. And then we went 30 miles an hour for 20 miles. So for 10 miles and another 10 miles for a total of 20 miles. Then we went 60 miles per hour for 30 miles. So that's 10 miles, 10 miles, and 10 miles for a total of 30 miles. We have to break this up evenly. So this is a nice little trick for doing this. This goes back to something you learned in 6th grade by breaking it up and looking at it. And then the last rate of speed was 50 miles per hour, but only for 10 miles. So this is what we have to add up. We have to break this up. So when I add this up, I get a total of 330 for miles per hour. Obviously, that's not the answer, but I'm finding the average. So there's 1, 2, 3, 4, 5, 6, 7 of these segments, breaking it up by 10 miles. So I'm going to do 330 divided by 7 to find my average. I wonder if it will still equal 45. Well, let's see. Turns out that it's actually 47.14 miles per hour if I round it off to the nearest tenth. Now you might say, well, it was close. And yes, it was, but it's not the number. So the answer to this is the average speed during the entire trip was 47.14 miles per hour. That was a bit of a challenge. If you could drive in a straight line back to the school from your last stop, how far would you drive and what is the name of the bus driver? Now, I asked you the name of the bus driver at the beginning. Do you remember what you said? I'm going to let you think about that one. So driving straight back means we would go from this point right here to this point right here. So we're going to go ahead and draw a line from those 2 points. What do you think you could use to help you find that distance? If you said the Pythagorean theorem, you are correct. The other thing that you could use is the distance formula, which is connected with that. We're going to go ahead and use the Pythagorean theorem. So I'm going to go ahead. So I'm going to draw a triangle to help me. I'm going to go from here down to here, and I'm going to go over this way. I'm going to get those measurements. On this side right here, we have 5, 10, 15, 20, 25, 30, 35, 40. And here we have 5, 10, 15, 20, 25, 30. You may or may not have noticed when I drew my path, I actually tried to make it with intervals of 1 to show the miles. You might not have done that. Since I've done this problem before, I knew to do that. So I'm going to let this equal leg A, I'll let this equal leg B, and what I'm looking for is the hypotenuse C. I'm going to write 30 squared plus 40 squared equals the hypotenuse squared, or C squared. 30 squared is 900 plus 40 squared is 1600, and that equals C squared. When I add these together, I get 2500 equals C squared. I want to know what C is, so I'm going to take the square root of both sides. We want the square root of C squared to undo it. So whatever we do to one side, we have to do the other. So we're going to take the square root of 2500. And you might have guessed that right away. It's equal to 50. So 50 equals C. So if the bus driver could go straight to the school, he would travel 50 miles. Did you figure out that the bus driver was you? So for me, the bus driver's name would be Mrs. Fink. If it's you, since it's you, it's your name. This concludes our school bus activity. I hope you found this fun. I like stuff like this.
The wheels on the bus go round and